In this, the second lecture of this course, we begin our narrative of human prehistory. And in this lecture, I try and give you an account of the earliest humans, or hominids, of all. Lecture 2 covers human evolution from about 7 million years ago, or just before that, up to 3 million years before the present. The first part covers humans among the primates, and in the suborder Hominidae. Then we consider the fundamental anatomical and behavioral changes which may have occurred among hominids before and after they separated from their common ancestor with the chimpanzees somewhere between 7 and 5 million years ago. The next part of the lecture examines the different fossil forms which define the earliest stages of human evolution, and we conclude that we must conceive of human evolution as a form of conceptual bush, as it were. And the lecture ends with the descendants of Australopithecus afarensis splitting into different lines about 3 million years ago. All of this is a very, very fundamental question for humanity. Indeed, it was the Victorian biologist Thomas Huxley who called the problem of human origins the question of questions for humankind. As long ago as 1863, he drew attention to the close anatomical relationships between humans and apes, which at the time was a highly controversial piece of research, which offended many devout Christians. And then, in 1871, Charles Darwin, of evolution and natural selection fame, theorized that Africa, with its rich and diverse ape populations, would reveal much about human evolution. The research of a century and a half since then has proved both Huxley and Darwin correct. Africa is probably the cradle of humankind. Today's paleoanthropologists, the scholars from many disciplines who study early human evolution, draw on researches in all manner of subjects to tell the story of the first humans. Molecular biology, in particular, has helped us pinpoint the moment when humans separated from our earliest, closest living non-primate relatives, the chimpanzees. All of us are members of the order Primates, which includes most tree-loving placental mammals. Within the primates, there were two suborders: anthropoids, apes, humans, and monkeys, and prosimians, lemurs, tarsiers, and other so-called pre-monkeys. The many similarities in behavioral and physical characteristics between the hominids, who are primates of the family Hominidae, which includes modern humans and their ancestors, and pongids, our closest living primate relatives, can be explained by identical characteristics that each group inherited millions of years ago from a common ancestor. Now, the basic anatomical pattern of the large hominids appeared during the Middle Miocene geological epoch, about 18 to 12 million years ago. By the late Miocene, about 8 to 5 million years ago, tree-loving, ape-like animals with long arms and legs abounded in Africa. These creatures were the ancestors of both modern non-human primates and hominids. And as we shall see in a few moments, a recent sensational discovery has thrown some light on these creatures. Now, the albumin protein substances found in primate blood have evolved at a constant rate. Now this means that the difference between the albumins of any pair of primates can be used to calculate the time since they have separated one from the other. As a result of this, we know that chimpanzees, our closest living relatives, diverged from a common ancestor shared with humans somewhere between 5 or 6 million years ago, maybe a little earlier. At the same time, there were dramatic environmental changes affecting tropical Africa, which, in general, appears, as I've said, to have been the cradle of humankind. These changes had a profound effect, we think, on the evolution of the first humans. At this time, primates abounded in thick African forests, in more wooded country, and also on the open savanna woodland, where they had grassland, where they had to stand upright to survive. Now, an upright posture and a bipedal gait, that is standing on 2 feet, are among the most characteristic human features. In the trees, a 4-footed posture is highly effective. One walks on one's knuckles like a football lineman. But in open country, endurance and the ability to cover long distances are vital, especially on the savannas, which, as Africa became cooler and drier, covered much of East Africa between 5 and 1 million years ago. Bipedalism, the ability to walk and run on 2 feet, made traversing this open savanna with all its hazards of predators like lions and hyenas much easier. And it had another effect too. It freed the hands. The hands could now be used to make tools. Unfortunately, we still know very little about the many primates who flourished in Africa between about 10 and 5 million years ago, this critical period of primate evolution. But we theorize that after about 10 million years ago, many primates spent more and more time on the ground, as it were, coming down from the trees. By 5 million years ago, Africa's climate was much drier. It favored more open country in many areas. Now this presented, with these extensive savannas forming, with the grasslands, open country, many new challenges for primates, especially a very fundamental one, the necessity to find food not just in trees, but over much larger areas, dozens of square miles. Mobility was absolutely essential. You had to be able to move fast, you had to be able to outrun dangerous predators, and you had to be able to run to take shelter. Out on the savanna, you didn't just reach into a branch and pluck fruit and edible leaves. The plant foods were dispersed widely over the savanna. You had to cover a lot of distance to acquire them if they were there. The result was that people began to rely, our earliest ancestors, more and more on meat as an essential part of the diet. Our earliest ancestors became omnivorous. They ate meat, they ate plant foods, but at the same time they became very, very mobile. And as we shall see, this was a characteristic of human foraging for thousands of years throughout prehistoric times. This is all theory. What do we know about the very earliest hominids. What fossils are there to reconstruct this earliest chapter of human evolution? The story comes from an extremely incomplete fossil record, largely because fossil beds for this critical period between 7 and 3 million years ago are very rare indeed. Back in 1924, a South African anatomist named Raymond Dart, a flamboyant character who had overhead bars installed in a lecture hall so he could demonstrate to his students how apes swung from branch to branch, identified a human-like primate from a site called Taung in the Cape Province of South Africa. It came to him in a piece of cemented breccia, which he chipped away laboriously to produce a fossil of a small primate with a rounded forehead, but a rather prominent jaw, lightly built. Now Dart named this small primate Australopithecus africanus, the southern ape-human of Africa. And he claimed it was a direct ancestor of humankind. At the time he was a young man, the scientific establishment rejected his ideas out of hand. But thanks to the work of another paleontologist, an eccentric Scotsman called Robert Broom, and other scholars since 1959, it has been shown that Dart was partially correct. Australopithecus, the southern ape-human in various forms, was one of the many roots of human evolution. The research of the next 3/4 of a century took the story of humanity back 5 million years. And then, in the year 2002, French paleoanthropologists Michel Brunet and Patrick Vinot unearthed a hominid skull in the Jarab Desert of Chad in the southern Sahara, which dated between 6 and 7 million years ago. That is to the period of this alleged splitting between apes and human stock. The skull is a complete puzzle. It's called Tumai. That's the name they gave it. It looks, from the back, like a chimpanzee. But it looks very much more human-like from the front, particularly in its teeth and the appearance of his face. It looks very much like a hominid of about 1 3/4 million years ago, the hominids we'll talk about in the third lecture. In short, Tumai is a puzzle. Brunet and his colleagues have nicknamed this fossil Tumai, but at the same time they've given it the label Sahelanthropus chadensis, the human-like creature of the Sahel from Chad. What exactly is this creature? What are the problems with it? The first one, and the French are the first to admit it, is that the dating is very loose. One would prefer to have a potassium-argon date for this, but there is no volcanic rock in this very, very harsh area of the Sahara. The date, which is based on the stratum in which it is found, is an estimate. It's the best estimate that can be produced, and it may be in the future that this date will be much refined. So, the dating is a little bit loose. Everybody agrees, however, that this is a fossil that is earlier than the famous fossils from Ethiopia and the rest of East Africa, which we'll talk about later. All the experts agree that this is a significant find, but whether it's a hominid or on the ape side is debated. Is this, for example, the ancestor of the fossils of about 4.5 million years ago, which are definitely hominids? Or is it on the ape side? At the moment, all we can say is that the find confirms that early human evolution wasn't very simple and linear. It was much more complicated, more bush-like than a straight line. Berkeley paleoanthropologist Tim White, who is probably the leading expert on human evolution at the moment, theorizes that Tomai was some form of ancestor of Ardipithecus ramidus, a hominid which he found in Ethiopia dating to about 4 million years ago. Until now, the earliest known hominid. But really, one must be honest and say that he is probably guessing. Why? Because we do not have enough fossils to be definitive. White himself will be the first to admit that he may change his mind as more fossils come to fill what is a huge black hole in human evolution. Those 2 million years between 7 and 5 million years, and just after that, when we know almost nothing. And this, of course, was the critical period when there was this division developing between the chimpanzee line and the human line. The next known fossil, which dates to between 4 and 4.5 million years ago, was a small creature called, as I've said, Ardipithecus ramidus. Ardipithecus stood upright. It had thin enameled teeth and a skull which looks much more like that of an ape than a human. In a way, it's a mix, like Tomai's. Ardipithecus ramidus was named by Tim White, who found it in the arid Awash region of Ethiopia. It's been potassium argon dated to about 4.5 million years ago, maybe a little later. It's only at this point fragments, so we really don't know very much about it. There's another early hominid too. This hominid is called Australopithecus anamensis, named after the local Turkana tribe's name for a lake, Anam. This primate flourished at the south end of Lake Turkana in Kenya. It is in some ways somewhat similar to Ardipithecus, in the sense that it's a mosaic of ape-like and human-like anatomy. The human-like limbs, but much less mobile hands than later hominids. It dates to about 4 to 4.2 million years ago and weighed between 104 and 120 pounds. Again, a mosaic of ape and human, but the less mobile hands are very significant because mobile hands are very important for tool making. So we have this period between about 7 and 4 million years ago, which is complete confusion scientifically. 3 fossils, all of them mosaics of humans and non-human features, all of them somehow connected with human evolution in its very early stages. It's very tempting to put them in a line and say, Tomai, Ardipithecus, anamensis, and so on. But in fact, at this time in Africa, we must realize that there was an astounding diversity of primates. Some of them closer to apes, other closest to the human line. And we only have the teeniest fraction of these populations. 3 fossils, maybe 6. Fragments, at the most, a dozen individuals. We don't really know. So really, it's a very early stage. But if you reflect that 20 years ago, the earliest fossil known was something like 2.5 million years ago. This is all extremely exciting. Probably the most famous of all the primordial hominids is a hominid nicknamed Lucy, found by Maurice Tayeb and Don Johansen at Hadar on Ethiopia's Awash River in the 1970s. This diminutive creature lived about 3.18 million years ago, stood about 3.5 to 4 foot tall, and was a form of Australopithecine, one of the ape humans made famous by Dart, the classic examples of which flourished around 2 million years ago. But it may have been an ancestor of the later Australopithecines. It flourished till at least 3 million years ago. So you've got Tomai, you've got Ardipithecus rhamnomensis, you've got Anamensis, and you've got Lucy, which is also known as Australopithecus afarensis, the Australopithecine of the Afar region of Ethiopia. All these fossil forms are profoundly confusing to layperson and to many scientists as well. As I've said before, a generation ago, people thought of human evolution as a straight line. It's much less confusing if mentally you think of it as a bush with many branches, one of which led eventually to the evolution of tool-making humans. If you think that way, then in some degrees all these Latin names don't matter so much. And if you just remember the words Australopithecus and Homo, that reduces it to two very simple lines: the Australopithecines and the human line itself. And we'll get back more into this in the next lecture. Probably the most dramatic evidence for what is probably Australopithecus afarensis comes from Laetoli in Tanzania, dating to about 3.59 million years ago. And this is one of these very rare moments in archaeology where a moment in time is frozen, just like a snapshot. This particular moment, 3.5 million years ago, two hominids walked across and through a dry riverbed. Now it so happened that they did so in the aftermath of an eruption by a local volcano, which had deposited soft volcanic ash on the ground and in this dry watercourse. They walked across this volcanic ash, which hardened in the sun, and the ash preserves their footprints. So just for this one moment, we can look at hominids as living people, not just fossils, their feet. This remarkable site was excavated by Mary Leakey, the wife of Louis Leakey, who was a very expert excavator. And she was able to establish these two hominids walked with a rolling, slow gait, with their hips swiveling at every step, quite unlike modern humans who stride freely. Unfortunately, the constraints of the studio prevent me from giving you a complete demonstration, but it's the difference between swinging your hips and striding. So, just for one moment, we see these creatures which aren't human, but clearly they have a part of the story of human evolution. These were but a few of the many hominid forms that flourished in East Africa 2 million years before the first tool-making humans appeared on Earth. somewhere around 2.5 million years ago. They are newcomers to us. We don't know much about them. The pace of discovery is slow but sure, involving multidisciplinary teams. And spectacular discoveries like that of Tomai are far and few between. But we know a number of things. As the hominids evolved, so did their brain size. This is a highly controversial aspect of human evolution, with some authorities linking greater brain size to the increased consumption of meat out on the savannas after 5 million years ago. Others believe that the need for more meat required an ability to use one's knowledge to develop ideas about where to find predator kills and the higher densities of animals. You see, these evolving hominids had a much more sophisticated interaction with the environment than non-human primates. The point is, if you are a hunter or a gatherer, as we find with later societies, even living hunter-gatherers like the San of southern Africa, one of the most vital components of their lives is intelligence, information about what lies over the horizon, beyond that outcrop of rocks, where the game is, where water is, and where wild vegetable foods are. And many people believe that the larger brain of the very first humans and of evolving hominids allowed for greater social intelligence, which allowed our very earliest ancestors to cope with the greater complexities of living in close juxtaposition to others. But we must stress that this was not just one hominid line. There was a tremendous diversity of hominids in East Africa and in other parts of Africa, many of which we haven't even discovered yet, who were undergoing processes of evolution. We know only the most general features of this. For example, at the very end of this first, very early chapter on human evolution, about 3 million years ago, the descendants of Australopithecus afarensis split into different lines, among them the earliest true humans. We're going to describe these hominids, the earliest tool makers, and also the earliest human behavior in the third lecture. In this lecture, though, we've looked at the very earliest chapter of all, at the environmental changes which caused it to be more open country. We've looked at some of the adaptations: larger brain size, upright posture, the need for greater mobility, the realities that living on the savannah you had to have a much more varied diet, which included meat, and of course meat requires either scavenging from big game kills, or running animals down, or trapping them, or even just simply throwing stones at them. You have to become adept at chasing and catching and stalking to get close to the animal, which, as we will see in a later lecture, is terribly important, where you've got to get so close that you can wound it fatally. We've looked at the very inadequate fossil story, which begins about 7 million years ago with the discovery of Tomai, somewhere around the time when apes and humans, the lines split from one another, if molecular biology is to be believed. And from there, we looked at hominids after 4.5 million years ago: Ardipithecus ramidus, Australopithecus anamensis, and Australopithecus afarensis, Lucy, and the remarkable footprints at Laetoli, which for just a moment give us a view of hominids as living beings. This then is the very first chapter of human evolution. In the next lecture, we'll pick up the story after 3 million years ago.